In this video, we'll take a look at notes for section 11.2, inference about two means when they're dependent samples. So we're going to test a hypothesis for a population mean from matched pairs data. So inference on matched pairs data is similar to inference regarding a population mean with only one set of data. Recall that if the population from which the sample was drawn is normally distributed and the sample size is large, then the test statistic t follow students' t-distribution with n-1 degrees of freedom. So we're going to analyze match pairs data. We're going to compute the difference in each match pair and then perform inference using methods of section 9.2 or 10.3. So how do we know if it's match pairs or not? So for match pairs design, to test the hypothesis, we have to make sure the following requirements are met. The sample is obtained by simple random sampling, or the data result from a match pairs design experiment. The sample data are dependent, this time match pairs. The differences are normally distributed with no outliers, or the sample size n is large. And the sampled values are independent, which means the sample size is no more than 5% of the population size. So notice in the step 1 what the hypotheses look like. The first is the mean of the differences. Notice that subscript D. Mean of the differences is equal to 0. Or for your null hypothesis, then your alternative, you're saying either that the mean of the differences is not equal to 0, less than 0, or greater than 0. So their by hand approach, again, I always include the formula, but we're going to use technology, both the TI calculator and then also StatCrunch. So that we're going to take a look at, here's our experiment. The problem is Professor Andy Neal measured the time in seconds required to catch a falling meter stick for 12 randomly selected students' dominant hand and non-dominant hand. So imagine you have your right hand, drops the meter stick, and they catch it with their right hand, drops the meter stick, then he catches it, the same person in the left hand. That's why this is matched pairs. It's the same person. Professor Neal wants to know if the reaction time in an individual's dominant hand is less than the reaction time in his or her non-dominant hand. A coin flip is used to determine whether reaction time is measured using dominant or non-dominant first. Conduct the test at the alpha equals 0.05 level of significance. The data obtained are presented in the table. So here are students 1 through 12. This is the time in seconds it took to catch the meter stick with the non-dominant hand, and the time that it took, or the dominant hand and the non-dominant hand. We want to verify, first of all, that the requirements are met. First of all, there's a random assignment of dominant or non-dominant hand for the experiment, so that's okay for random assignment. The data are dependent, matched pairs. The same person is catching a meter stick with their dominant and non-dominant hand. The sample size is below 30. Oh, so that means we have to check and make sure that they come from a normal population. So we have to find the differences and create a normal quantile plot to check for normality and a box plot to check for outliers. So this is a reminder of back what we did in chapter 7. So first thing we do is we take the differences between the two data sets. So notice our differences are dominant minus non-dominant. That's important. So we get the differences. So I'm going to pull up StatCrunch. Your calculator will do a QQ plot and a box plot as well, but StatCrunch is actually better for this. So in StatCrunch, I've got the data values of the differences already typed in. So a reminder, these are both graphs. The first one is a QQ plot. Select the variable. Correlation statistic would be okay. Compute. We just want to check and see if it's approximately linear or not. So there's the QQ plot. And a reminder, also a box plot. This was back from our chapter 3. We're going to use fences to identify outliers. It doesn't matter whether it's horizontal or vertical. We just want to know if there are any outliers or not. So these are the two graphs we check when we have a sample size that's small. So here, the plot looks linear, the QQ plot. So yes, it looks like they come from a normal distribution, and there are no outliers in the box plot. So the sampled values are independent. The sample size of students is definitely less than 5% of the population of students at that college. So now that we have the requirements verified, we're going to go ahead and use the calculator and also StatCrunch. So the null and alternative hypotheses. Null is always the mean of the differences is 0 seconds. Then if the question is the reaction time in the dominant hand less than the reaction time in the non-dominant? So if we took dominant minus non-dominant, then we're checking to see if the differences are less than 0 seconds. Are they faster? So what we're using in the calculator, I have the values typed in. I'm going to real quickly find the differences in list 3. And for list 3, I'm going to type, I want list 1 minus list 2. So my differences are in list 3. So I'm going to go quit, stats. We're running just a regular t-test. Okay, so we end up with one set of data after we subtract. For the t-test, I'm using data instead of statistics this time. Then I have to tell it what my null hypothesis is, which is 0. Where is my data? I've got mine in list 3, so I have to hit second, the number 3. Frequency means just 1. We're counting each data value once. And then we want to make sure we have the correct hypothesis test, which was less than 0, and hit enter. Oh, down to calculate, and then hit enter. So there's our t value, our test statistic of negative 2.775, and a p-value of 0.009. If you're going to use StatCrunch for this, get rid of these. This is in tests. This is a t statistic. It's one sample with data. So you tell them where the data is. It's a hypothesis test where the mean equals 0. The alternative is the mean is less than 0. Compute. And we'll get the same values as we did in the other if I type them in correctly. All right, so I think I might have typed the values in not correctly, but you get the idea. All right. So step 4, we're going to reject the null hypothesis because the p-value 0.009 is less than the significance level of 0.05. That says that there is evidence to show reaction time in the dominant hand is less than reaction time in non-dominant. Then, second objective, we're going to go ahead and interpret a confidence interval. These are the formulas, but we're going to conduct it using technology. On the calculator, we're going to clear and go to stat, tests. This is a t interval. We have data again from list 3. The confidence level, since this is a one-tailed test, is 100% minus 2 times alpha, so we have a 90% confidence level. Calculate 0.0217 to 0.0046, so this should have a 0.0217. So the interpretation is we are 90% confident that the reaction time with the dominant hand is between 0.0217 and 0.0046 seconds faster than reaction time with the non-dominant hand. Notice the whole interval is less than 0, so that supports our conclusion in the hypothesis test. We wanted to know if the difference was less than 0. The difference in reaction times are negative, which means the reaction time for dominant hand was faster than non-dominant. So steps on StatCrunch. I think I probably have one of these typed in incorrectly, but on StatCrunch, these are stats, t-stats, one sample with data. exactly the same and come down and select confidence interval this time. And you have to put in the confidence level. Hit compute, and if we had the, then it would come up the same as my other. All right, so that's how to use both StatCrunch and the calculator